We talked about how to graph these functions already, how the A, B, C, and D affect the actual graph. We also talked about how to take different features like the amplitude, the period, the phase shift, and the vertical shift and actually translate it into an equation. Now we're putting all those things together and we are actually going to apply it to real life situations, okay? So some of the main things that you need to be aware of, that you need to make sure that you know how to do, is you need to know how to find the amplitude of a function, because these are coming from word problems, okay? It's not gonna be a graph now for you to say, oh, well, I can find the midline, the distance between my midline and my max. You're not gonna be able to do that. You're gonna need to actually be able to identify how to find the amplitude, which means you'll probably need a formula. To find your amplitude, you'll take your maximum height or your maximum whatever, and then you are going to subtract it from your minimum height or your minimum whatever and divide by 2. That is how we find the amplitude in word problems, okay? Because essentially that's what you're doing. You're finding the, you're essentially finding that distance from the midline to a maximum. Not to be confused with a vertical translation. Your vertical translation is your max plus your min divided by 2, okay? Because it's the averages between your highest value and your lowest value that gives you your midline. And that essentially represents your vertical translation. Your horizontal translation is found by that right there is your phase shift, okay? So you'll still need the formula of negative C over B, okay? That is still your phase shift. So you need that formula, negative C over B. And on top of that, because we're going to be writing cosine functions, you also want to be able to make sure you're able to identify your maximum value, okay? Because you'll need the X of your maximum value. And then lastly, the period. Since we are writing a cosine function, we will need the formula 2 pi over b. But remember, the period is the horizontal distance from max to max, min to min, or you take your maximum minimum distance and double them, okay? However long it takes to complete one full cycle. Remember, that's the definition of period. So you'll need to have all these things, essentially everything we've done up until this point. You'll need to create these equations to model these real world situations. And again, you're going to be creating a cosine function. It's easier to do because remember, on a cosine function, it's easy to identify where the maximum occurs because normally it occurs on the y-axis. So if it's been shifted off of the y-axis, it's able to find that phase shift. Unlike a sine function that technically starts at the origin, and so it's been shifted any type of way, stretched, it's a lot harder to find that point, this point right here, than it is to find a maximum value. However, if you do want to write a sine function, remember, it has the same amplitude, the same vertical translation, and the same period. But for the phase shift, that horizontal translation is 1/4 of the period to the left of the cosine curve. I'm never going to ask you to write a sine function. But if you are so gung-ho on writing a sine function, that's exactly how you find that C value in the equation. All right, and I'll show you on one of these how to do that. Everybody have this information written down. Use the information to the left or underneath to write the sinusoidal function that models the number of hours of daylight for New York City as a function of x, where x equals 1 represents January 15th, x equals 2 represents February 15th, and so on and so forth. Use your model to estimate the number of hours of daylight on September 30th in New York City. With working with this, you need to identify, okay, what is my maximum value? Clearly, x represents my months. That would technically go on my x-axis, my hours of daylight, that's my y. That would go on my y-axis. I need to identify what's my maximum hour of daylight and which month it occurs in. So take a look at your data. Where does the maximum occur? Occurs in June. June would represent, technically based off of this, if 1 is January, 2 is February, June would be what number? 6, okay? Then you have to identify your minimum. What's your minimum hours of daylight? December, okay? So you want to make sure you identify your minimum and your maximum, because remember, I need my min plus my max divided by 2 to find my vertical translation, and I need my maximum minus my minimum divided by 2 to find my amplitude. That's A and D in our equation, right? So that's exactly what I'm going to do. I'm going to find A and I'm going to find D. So I take my max, I'm going to subtract my min, and then I'm going to divide that by 2, and that's going to give me the A in my equation. I'm going to write it down here in case you forgot. It's A cosine bx plus c plus d. I'm basically trying to create that equation. So can you guys go ahead and subtract those, divide by 2, and tell me what we get? 2.9?
Yeah, 2.9.
So that's going to be the start of my equation. Then I'm going to add them and divide by 2 to find D. So add them and then divide by 2.
$12.17.
12.17. You said 17. So then I have D. Okay, so far we've created half of our equation. Now we got to find B and C. B and C are going to involve a little bit more. So to find B, we need to know what our period is. Okay, now a lot of students like to say, oh, well, if this represents the calendar year, it's going to essentially repeat the same cycle every year, and they want to automatically say that it's 12. You can't do that. You have to base it off of where the maximum and the minimum are located, because we're trying to find the best model to represent this situation. So the easiest way to do that is look at the difference or the distance between your max and your min, where they're located. From 6 to 12, how far is that?
6.
It's 6. So that essentially represents from a maximum value to a minimum value, that distance is 6. And so if we double that, we'll find the full period, which is what? 12. So my period is equal to 12. So I'm going to take that, I'm going to set it equal to 2 pi over b, because that's the formula that I have that's associated with the period. This will allow me to find the value of b, which is another piece in my equation. So I'm going to multiply both sides by b to get b out of the denominator. Then I'm going to divide both sides by 12. When I reduce that fraction, b is equal to what? Almost there. To create my equation. Last thing I need is my c, which is a part of my phase shift, okay? Now, to find your phase shift, since we are writing a cosine function, remember, it's the horizontal distance to when you reach your maximum point. Our maximum occurs in June. So that x value that corresponds to the maximum is our phase shift. The x value of where our maximum occurs is our phase shift. So since the x value where our maximum occurs is our phase shift, I'm going to set 6 equal to negative c over b to find the value of c. I just found that b was equal to pi over 6. So I'm going to plug in pi over 6 for B. I'm going to multiply both sides by pi over 6 to get pi over 6 out of the denominator. What's pi over 6 times 6?
Pi.
So pi equals negative C. So C is equal to a
Negative pi.
So now I have all the pieces to write the model that represents the hours of daylight for New York City. It is y equals 2.9 cosine pi over 6 x minus pi plus 12.17. So the last part of the problem says to use your model to estimate the number of hours of daylight on September 30th in New York City. Well, remember, 1 represented January 15th, 2 represented February 15th, 6 technically represented June 15th. So what numerical value would represent this, September 30th?
9.5.
It would be 9.5 because 9 would have represented September 15th. Their September 30th is half, the other half of the month, so it's 0.5. So to actually find the hours of daylight, I'm actually going to plug in 9.5 for x into my equation and solve for y to get my hour of daylight.
Wait, how do I get 9.5?
Since 1 represented January 15th, September 15th would have actually represented 9 if we were following along in that same pattern. And September 30th, that is actually the end of September because it's 30 days in September. So that's the other half that would account for, you know, going to October 15th, which would be 15 days later. So September 30th is halfway to October 15th. So using those context clues from the problem help us determine that September 30th is 9.5. So I'm going to type this in. Let's see if we got the same answer. So 2.9 cosine pi over 6. We are in pre-cal. We do not use 3.14 for pi. I'm actually going to put that in parentheses to make sure that the calculator knows I want pi over 6 first, then multiply by 9.5. Minus pi, close out the parenthesis, plus 12.17. Real quick. Okay, just want to check something. Did we get 11.4? Yes?
Yes, ma'am. Yes, ma'am.
Good. The average monthly temperatures we said at Washington are showed. Make sure you change that May to a 56. Write a function that models the monthly temperatures using x equals 1 to represent January. So if you do that, this is 1, 2, 3, 4, and so on and so forth. Identify your maximum and minimum. Where does your max occur?
August.
August. Where does my min occur? Remember, don't get in the habit of saying, oh, it's a calendar year, so the period is automatically 12. You really need to locate where the max and min is so that way you can get an appropriate model for this, this data. So let's find A, B, C, and D. To find A, which is our amplitude, essentially, we are going to take max, we subtract it by our min, and divide by 2. What you guys get for A?
12.5.
D is the opposite. Don't get those two mixed up. Do not get those two mixed up. What's 66 plus 41 divided by 2?
53.5.
53.5.
Good. Now, to find B, I need to identify what my period is. Remember, since I'm trying to find the best model for this, I take the distance between my max and my min and I double it. So it's gonna be 14, because that is 7 months from January to August. So then I double it to get 14. I set that equal to 2 pi over B. Multiply and divide. B is equal to what value?
507.
And your phase shift is the X value of your maximum. What's my X value of my maximum?
8.
That is going to equal negative C over B, or in this case, negative C over pi over 7. I multiply both sides by pi over 7 to get, well, 8 pi over 7 first is equal to negative C. And so then C is a negative 8 pi over 7. So I have A, B, C, and D. Any questions on how we're getting these equations?
Miss Anderson,
Yes.
for the period, where did you get 14 from?
You take your maximum and your minimum X values and you subtract them. And then you have to double them to get the full period.
Okay, thank you.
You're welcome. So that's our answer to part A. According to our model, what is Seattle's average monthly temperature in February? February corresponds to what value?
2.
2. So that means I want to plug in 2 for X and find Y. Y represents the temperature. X represents the month. So type it in. Let's see if you get the answer. So both of the 2 examples you guys have had to come straight from data. Okay? 2 you've had to come straight from data. So let's take a look at a problem that's not data-based. I know the next one is another data-based one, but I want to give you one that's not a data-based one. So look at the next page of your notes. Okay, I'm gonna skip this one, but I think by now we're comfortable enough to take a data one, find A, B, C, and D. Okay, let's look at one that doesn't have data. We actually gonna have to read and decipher and pull out the information. Okay, 13. A buoy. It's that little thing that's in water that bobs up and down. Okay. Usually at the beach, they pull out a little buoy. They basically say, do not go past this point. The shark gonna get you. Okay. A buoy. It's bobbing up and down in the water as waves pass it. Moves from its highest point to its lowest point and back to its highest point every 10 seconds. The distance between its highest and lowest point is 3 feet. If you think about how a buoy is bobbing in the water, it goes up and then down, and then up and then down. It looks like a what? It looks like the cosine function, the sinusoidal function. So we can use a sinusoidal function to model this situation. In part A, it says determine the amplitude and the period of the function that models the bobbing buoy. Okay? So if it bobs up and down, moving from its highest point to its lowest point every 10 seconds, then what is its period? If it's moving from its highest point back to its, or lowest point back to its highest point every 10 seconds. Is it 10 or 20?
10 since bottom because I'm 10 and then the full period.
It's 20 seconds, right?
It's gonna be 20, because if I go from my lowest point to my highest point every 10 seconds, then from my highest point back to my lowest point is going to be another 10 seconds. So that's a total of 20. Or hold on, moves from the highest. Oh, never mind.
To its lowest point back to its highest point.
My mistake. Yeah. Let me read the whole problem. Moves from its highest point to its lowest point and back to its highest point every 10 seconds. So that is actually our period, 10. That's going to help us with modeling our sinusoidal function in part B. But let's find our amplitude. It says the distance between its highest point and its lowest point is 3 feet. So from its highest point to its lowest point, that's a total of 3 feet. So then what would our amplitude be?
1.5.
It would be 1.5, because if you think about it, the amplitude is max minus min divided by 2. I already have the distance between my maximum and my minimum to be 3. So then I just divide it by 2 and I get 1.5. So now we have to write an equation of a sinusoidal function that models the bobbing buoy using x equals 0 as its highest point. So if that's the case, then x equals 0, technically, that would be my y-axis if I were to actually graph this. So that means that my highest point, my maximum is actually on the y-axis. So that means there is no phase shift, because x equals 0 is at its highest point. In other words, it's at its max. So I have no phase shift. Does the problem tell us anything about a vertical shift or anything like that? No, it does not. So there's no vertical shift either. And if you really think about it, a buoy goes like up and then down, like a little up and then down. So it's equally moving along the water line. So I have no phase shift and no vertical shift. So I just have a period and an amplitude. Since my amplitude is 1.5, I can plug that in there, and the highest point is at 0, so it's not negative. Only thing I need to find now is B. Find B. Very good. It is pi over 5, because remember, you take your period and you set it equal to 2 pi over B, multiply both sides by B, and then divide by 10. And there's your equation to model this buoy. So with non-statistical problems, non-database problems, you have to read it. You have to see, okay, let me pull out this information. Let's do this one. It should be on the back of that page. As you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at a position shown in the diagram. Okay, so this is where you start on that Ferris wheel at the bottom. You happen to be 5 feet above the ground. Let T be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 12 seconds to make a revolution. Everybody know what a revolution is? One time around. The diameter of the Ferris wheel is 55 feet, as you can see in the picture. When you begin, your seat is 5 feet from the ground. What is the period? It is 12 seconds, because it says that it completes a revolution in 12 seconds. So my period is 12 seconds. Then it asks you for all of the pieces, so then that way you could write your equation and even sketch your graph. The next one asks you for your amplitude. Remember, amplitude is max minus min divided by 2. I need to know my maximum what? Maximum time? Height. What's the highest that this Ferris wheel goes?
60 feet.
It'll be 60 feet because you base it off of the ground. What's the lowest that it goes? 5. So I do 60 minus 5 divided by 2. And what's 55 divided by 2? Since I'm on this side, let's do vertical shift as well, because I take the same values, I just add them and divide by 2. What's 65 divided by 2?
32.5.
Again, we got 60 because we're basing this off of our position from the ground, okay? Now the phase shift. The phase shift is standing at horizontal distance till you reach your maximum. Well, horizontal in this case is representing our time. So how long is it going to take for this Ferris wheel to make it to its highest point?
6 seconds.
Exactly, it's 6 seconds, because if I start at the bottom at t equals 0 and it takes 12 seconds to make it all the way around, that thing is going fast. To go all the way
Yeah, that's
around.
what I was thinking. I was like, oh my goodness.
It's gonna be half the time to reach the maximum. You better hold on for dear life.
That's not fair.
Yeah, that's
Roller
cool.
coaster.
And it's like 55 feet in
Ooh.
that. That's crazy.
Yep, yep. Hold on to the little harness. All right,
I don't have that.
so we're gonna sketch the graph of this sinusoidal function. So to do that, we're gonna need an x-axis and we're gonna need a y-axis, and we're gonna need some labels. My x-axis is indicative of what in context of the problem? Time. While y represents what? The height of the Ferris wheel. Now, when you start at time t equals 0, how high are you above the ground? You're at 5 feet. So you start here. Then you continue to go up to what height?
60.
To 60 feet. And then you go down back to 5 feet. Then you go up and back down. And it repeats. At what time were we at our maximum height?
6 seconds.
6 seconds. So then what time would I be back to my low height, my minimum height?
12.
12. And if I keep repeating this pattern, when's the next time I'm going to be at my maximum?
18.
Exactly. And it continues from there. And this would be the graph, the sketch of my sinusoidal function. I have labels on my x-axis and my y-axis. Both have their labels. And now from here, especially with a visual, I'm going to see that my cosine function, if I don't include a phase shift, my A is going to have to be what? Negative. Because I have a minimum on the y-axis. But if I do a phase shift, which I can, then my A will stay positive.